So as we think about atoms coming together to form molecules, one of the main rules that Lewis came up with that largely is followed, though not completely, we'll see exceptions to this rule, think of this more as a guideline than a rule, is what's known as the octet rule. Now, why is it called the octet rule? Octet means 8, a set of 8. So what it means is that we want, atoms generally want to have a set of 8 electrons around them, like the noble gases. So we've mentioned this a couple of times in this class already at this point, but generally that is the most stable configuration of electrons, is to have a full valence shell, just like the noble gases do. And this is why the noble gases generally don't participate in bonding, because they already have their full set of electrons. The one exception, one of the main exceptions, there are many exceptions, one of the main exceptions to this is hydrogen. Because it only has a single electron, it wants, instead of an octet, you could say it has a duet rule. Hydrogen wants to have 2 electrons shared between it. But there are other exceptions. You can often have things with less than or more than an octet, but this is a good starting point. Most things are going to follow this octet rule, and then we'll look at exceptions to this as we move forward. So how does this show up? So let's look at something like carbon. So again, our Lewis symbol for carbon is we have 4 dots to represent our 4 valence electrons, and we want to, so that, how are we going to get more electrons into carbon? Well, carbon's going to have to share with another molecule, or with another atom, to get to that full set of 8 electrons. And so we can say, look at something like hydrogen. I'll use hydrogen here to keep it simple. Hydrogen has 1 electron, and it wants a duet. It wants the 2 electrons. And we can get 4 different hydrogen atoms here. And now, if they share, this hydrogen will have 2 electrons, this hydrogen will have 2 electrons, this hydrogen will have 2 electrons, and this hydrogen will have 2 electrons. So now all the hydrogens are happy, and since they're sharing, the carbon has 8 electrons once we've shared these valence electrons. The way we write these, when they in this sharing of electrons, this is what we call a single bond, where there are 2 electrons shared between these atoms. The way we represent this in a Lewis structure is we write a line between each atom in the structure here. And so this is the molecule methane, where carbon shares its electrons with 4 different hydrogen atoms, and we form this molecule methane. And so when you see a line in a Lewis structure, this represents a pair of electrons. So if you're counting to see whether something is following the octet rule, you always need to make sure to count 2 electrons for every line that you see, for every bond that's formed between molecules. So that's an example of how the octet rule is going to show up as we do Lewis structures. And so a lot of the rules around Lewis structures, or how to draw Lewis structures, really come back to this idea of atoms want to form these octets, and we're going to share the electrons between the atoms to make that happen. So in the next video, we'll look at some of the guidelines, or the sort of step-by-step you can follow to actually draw Lewis structures of molecules, and do some examples.